All right, so in this review, we were talking about different ways to solve quadratics, and we actually did one of each of these in class together, so I'm just going to throw another one on here. I'm going to start with number 2. So for number 2, your goal is to be getting x squared alone. So I'm going to start by adding, wow, let's try that again. I'm going to start by adding 45 to both sides. When I do that, I get 5x squared equals 45. My next step is going to be to divide both sides by 5. That'll leave me with x squared equals 9. Then to undo x squared, we square root both sides, and hopefully by now you all know the square root of 9 is 3. Now when you take the square root of a positive number, you always get a positive and a negative answer. So our answer for number 2 is going to be positive and negative 3. I'm going to go down and do number 8. And this is a completing the square question. Now in class we did number 7 where you had to divide out that 9 first, but because we don't have any coefficient in front of the x squared, that is an unnecessary step here. So I'm still going to separate those guys, but I don't have anything to divide by. So I'm looking at the 2. I need to divide that in half, which is 1. And then I square it and get 1, and that's the number I need to add to make a perfect square trinomial. So I have x squared plus 2x plus 1. And then I still have that minus 7, and I added 1 in, so I need to subtract 1 out. Sorry about that. And that gives me 0. The whole reason we did that is so the first piece would factor into x plus 1 squared. And I have a minus 8, and that is 0. I'm going to add 8 to both sides, and I get x plus 1 squared equals 8. And then I would square root both sides. I get x plus 1 equals positive and negative 8. I'm sorry, positive and negative radical 8. And then I would subtract 1 on both sides, and that will give me x equals negative 1 plus or minus radical 8. Again, we did number 13 in class, so I'm going to take a look at number 14, and we're looking at the same thing. I'm going to take that piece right there. 14 is my middle term, so I'm going to do 14 divided by 2, which is 7. 7 squared is 49, so that's going to be what I'm adding to that piece. So I'm going to have x squared plus 14x plus 49 minus 49 to cancel it out, and plus 50, and I did that again, so the piece I just put in parentheses becomes a nice square for me. It's going to be x plus 7 squared, and hopefully we know that 50 minus 49 is 1. So in vertex form, it's x plus 7 parentheses squared plus 1, and didn't ask for it, but a side note is that the vertex of that formula, or of that graph, would be at negative 7, positive 1. Alright, so on the back side of the worksheet we are talking about the quadratic formula as opposed to completing the square. And the quadratic formula has been given to you, and we can use part of the quadratic formula called the discriminant to determine how many solutions there are. I want to remind you that if that square root piece is positive, you'll have 2 solutions. If that square root piece is negative, you will have no solutions. And if that square root piece ends up being 0, that gives you 1 solution. So that's all we're looking for in 16 through 21. So if I go to, I'm going to look at number 17. You'll notice that it doesn't equal 0 right now, and that's a big issue. When we're using the quadratic formula, we always want one of those pieces to equal 0. So I'm going to start by subtracting x and subtracting 2 from both sides so I get that 0. That's going to give me 6x squared minus x minus 2 equals 0, and that's what I'm going to work with. From there, my a value is 6, my b value is negative 1, and my c value is negative 2. Those are just the numbers, the constants and the coefficients, and I'm going to use that b squared minus 4ac to figure out if I'm positive, negative, or none. So I have b squared minus 4 times 6 times negative 2. and negative 1 squared is positive 1. 4 times 6 is 24. Times 2 is going to be 48. And I have a negative here and a negative here, which makes that a double negative. So that's really plus 48. And that gives me 49. Because that is a positive number, that means that I'm going to have 2 solutions. And then there are opportunities on the exam for you to actually use the quadratic formula. So I'm going to take a look at number 23. It's already solved for 0, so that's good. My A value is going to be 5. My B value is negative 6. And my C value is negative 2. I'm going to plug it right into that quadratic formula which you were given. So it says negative 6 plus and minus the square root of negative 6 squared minus 4 times A times C. Whole thing's under the radical, and all of that is over 2 times negative 6. So when I simplify this down, the double negatives become positive 6. 2 times negative 6 is negative 12. And then we've got 6 squared is 36. 4 times 5 is 20. Times 2 is 40. And I have that double negative again. So that's going to be plus 40, which gives me radical 76. And the best news about this question is radical 76 is not one that we know a square root of. And 76 might be divisible by 4. Let me check and see if we can reduce this at all. 76 is divisible by 4 19 times, so I can say that that's radical 4. Radical 76, wow, that's bad. Radical 4, radical 76, which would be, I'm sorry, not 76, that's radical 19. And radical 4 is 2, so this is really 219. It's 6 plus or minus 2 radical 19 over negative 12. And because 6, 2, and 12 are all divisible by 2, I can actually do that. 6 divided by 2 is 3. 2 divided by 2 is 1, so I don't need to put anything there. And 12 divided by 2 is negative 6. So right here, 3 plus or minus radical 19 over negative 6 would be my final answer.